Hello, everybody. I hope you all are doing well. This is just a follow up on the previous video I posted where we're going to go over some additional problems, hopefully, ones that have to do with centrifugal force, as well as other things you might find on the test. So, yeah, without further ado, or with one quick ado, let's get into it. That ado is if you have questions, SAS has a Teams page. Go on here. We have, in addition to physics, we have all three calcs where you can ask questions, as well as the chemistries and EP2, which a lot of you might be taking next semester. So, yeah. If you're at all interested, this is the best way to reach us on Teams. And if you can't get on Teams, email me at bryce17@ksu.edu. So with that out of the way, let's get on to the problems. The first one is centrifugal force. So right here we have a car going up and then down a hill. Its mass is 25 kilograms, and the radius of the hill is 10 meters, and with a velocity of 5 meters. So the first thing we should do here is draw a free body diagram for the car. So at this point, the problem is asking how much normal force will be on the car. So very first thing we always want to have is force gravity, and then since it's on a surface, we're also going to have force normal. Then also, since we're going up in a curve-like motion, we're going to have centrifugal force. That will also be going up. And we know it is going up because centrifugal force will always go to the outside of the curve. So right here, it's going to the outside, away from the center. Down here, it'll be going to the outside, away from the center. So the first thing we want to do here is pretty much remember that the forces, if the car isn't leaving the hill, that means the forces going up are going to be equal to the forces going down. So we know that Fc is equal to mass times v squared over r, and then also Fg is equal to mass times gravity. And then if we set up this equation, we have our forces that are going up. We got Fn, force normal, plus our centrifugal force is going to be equal to our force of gravity. I believe our force of gravity is going to be 245 newtons. Also, if I go a little fast, I'm sorry. I already recorded this once or tried to record it once, so this is my second time going through, and it's pretty late. But I'll still have the whole solution up here, so hopefully you'll be able to all follow along. But yeah, like all I'm doing here is just using this, plugging in the numbers to get the this is going to be equal to 62.5. We're going to plug these values in, and that's going to give us an answer of 245 newtons minus 62.5 newtons is going to be equal to Fn. So Fn is going to be equal to 182 And that's our answer here. Then it wants to know what the normal force is at the bottom. So right there, we're just going to do a force body diagram right there. Once again, we have F normal coming up and gravity coming down. Now, and then this time, since we're on the bottom, the centrifugal force will actually be coming down with gravity. So our equation will actually look like F normal is equal to Fc plus Fg. Now, since we already calculated the force of gravity right here, and the force of centrifugal force, and none of our variables changed, we don't need to calculate them again. We can just plug in these values and get our F normal at the bottom is going to be equal to 307.5 newtons. Cool? Alright. And now we're on part C, where the car is driving at an unknown velocity, so we want to figure out what our V is. Or no, yeah. We want to know what the normal force at the bottom is, so Fn, and our velocity, given that the normal force at the top was 0. So the very first thing I'm going to do here is construct the force body diagram for the top. Since we have force, which is basically going to be this. However, since force normal is 0, our free body diagram is just going to look like Fc going up and force gravity going down. That means our centrifugal force is going to equal our gravity, which will allow us to then calculate the velocity, because we already know that gravity, that's going to remain constant. So we got 245 equals Fc, which equals mass times V squared over R. And then we just got to plug these values in, and that gives us a final, or we have to plug in those values, which are 2.5 times V squared. At this point it's just algebra, and I'm going to skip to the end real fast and get that our velocity is roughly 9.9 meters per second. How we did that was just taking 245 newtons, dividing it by 2.5, and then taking the square root. As for the bottom force, we're going to calculate they next want to know what is the normal force at the bottom. So we're going to construct a free body diagram. We got Fg going down. This one's going to look the exact same as what we did for part B. We got Fn up top, Fg going down, and Fc going down. So we know that Fc is once again going to be equal to 245, as is Fg. So our Fn is going to be equal to 245 multiplied by 245. Each of these are newtons, always remember the units, because that is the type of stuff they take off on tests. And our final solution for normal force at the bottom is going to be 490 newtons. Hopefully that problem makes sense. Yeah. And now we're going to move on to the next problem. In this one, I guess we didn't get the ramp on this one, but a child is sliding down a ramp of 30 degrees. And it has an acceleration of 1.5 meters per second squared. So what they want to know is the normal force of the ramp on the child. So what I think we should do is draw a free body diagram. So on the child, we have force of gravity acting downwards. Then parallel with the perpendicular with the slope, we're going to have force normal. And then and then eventually we're going to have friction going back parallel with the ramp on the child. Pulling it up, slowing it down this way. So those are our three forces acting on it. And then you see and then they would normally like it if we turn this into an X and Y plane. We shifted it 30 degrees. So that up here is Y and over here is X. The reason for this is it makes it easier to isolate the forces. You'll see right here, well, it makes it generally easier to do the sum of the forces is equal to 0. But for now, we're just going to split up the force of gravity. So with the new X and Y axis, we're going to split this into Fg of Y and Fg of X. And this right here is going to be 30 degrees. So Fg of Y is going to be equal to cosine, because it's adjacent, 30 times Fg, and then G of X is going to be equal to sine of 30 times Fg. So it's just the regular triangle rules. We just split it into an X and Y. One way to check if you also did this right is that when you are done, your Fgx and your Fgy should both be less than your original Fg. That's one way to check to see if you did it right. Like if either of those two are bigger, the legs of a triangle should not be bigger than the hypotenuse. But anyway, I'm gonna skip. This one is pretty basic algebra. Fg is equal to 9.8 times 10, so that's 98 newtons. You plug that into this equation, we're going to get Fgy is equal to, hop over to the other one real fast, 84.9 newtons. What we want to do then is, well, compare every force in the y direction. So if we examine just the y direction, the only force we have going up this way is force normal, and the only force we have going down is Fgy. Thus, since it's not leaving the ramp, we can set these two values equal to each other. So force normal is going to be equal to Fgy, which is then 84.9 newtons. So that's our answer there. And now we want to go on to part B. So we want to solve the coefficient of friction. The first thing we're going to want to do is calculate the force of friction. In order to do that, we're going to want to figure out the total force going down the ramp, because unlike in the y direction, the x direction does have an acceleration. So we're going to turn back to this equation. The sum of forces is going to be equal to the acceleration times mass. Or I guess that m should be on the other side, but so what we want to do is just take this 1.5, multiply by 10, we get 15 newtons. And it's an acceleration of 1.5, so it's accelerating this way, which means the force, the 15 newtons, is going to be going down this way. So now let's draw, just like what we did with y, we're going to check out all values going in the x direction, so free body. The only thing we have going down in the x direction is Fgx, and the only thing we have going up is F friction. As a result, we can say that Fgx minus the force of friction is going to be equal to our total sum of forces, 15 newtons. And with that established, we can then plug in our values here to solve for Fg of x. I'm going to skip over the algebra. Sine of 30 is just 1/2. So that means that this is just 49 newtons. So 49 newtons minus force friction, that gives us force friction equals 34 newtons. We also know that the equation of force friction is the constant. In this one, it's going to be K, because we're assuming if it's an body in motion, then it's going to be kinetic friction, and then we're going to multiply that by normal. I will say, granted, it doesn't say whether if it was stopped or is not in motion, we would use static. So if it doesn't specify, I would probably advise going with kinetic if it doesn't say that it's stopped. But either way, if they're asking you to find coefficient, it should still result in the same answer. So anyway, all we have to do is just take our 34 divided by our force normal, and we get our constant is equal to 0.4. And since this is a constant, it is one of the few things that will not have a unit. So you don't want to put anything at the end of this. This is just 0.4. And with that now done, we have C. So they want to know how, if the friction force was 10 newtons, how do we set up the x and y equations? So as pretty much the first thing, let's do y first. There's going to be no impact. If they actually ask this on test, I would suggest just writing out the same equations, but I want to save time. And I don't think you guys need me to write out the same equations again. But pretty much, since neither of these are affected by friction, these will stay consistent. So in the term of the x direction, we can say that our total force will now be equal to f g of x subtracted by 10 newtons, and that would be the real impact. It wouldn't change a whole lot. It wouldn't change anything in the y, and for x we would just substitute in a different value. And alright, so that was problem 14, or just the second problem. Right here we have our third and final problem. So in this problem we have a ball that's on 2 ropes. It's then swung in a horizontal direction like this. It's going to be going around this pole. Without going up or down or really changing its radius. So first thing they want us to do is draw a free body diagram. For this problem, we're going to call this T top, and we're going to call this one T bottom. We are also going to assume they are both pulling us this way. In truth, ropes could be pushing the other way. If you're worried about that, don't be, because even though we're assuming they're pulling inward, if they're actually pushing the ball out, then they will turn up negative, which I think will happen for one of these. So I'll explain what that means if you get a negative. But first, let's set up a free body diagram. So we got the ball here, we got force gravity going down. There will actually be no force normal, since it's not touching any surface. We will have Fc, since it's spinning around, and this would be the outside of the radius. We then have T bottom pulling us down this way, and T top pulling us up this way. So that's the free body diagram. Hopefully those forces all make sense. We're now going to do B, which is where we separate it into X and Y. Let's do X first. So gravity does not affect us in the X direction. What we are going to do is split these up into TBX, split this into X and Y. The reason for us splitting the tension into X and Y is so they can fit into these X and Y equations. X, T, T, Y. So what we have here is both the tension of the top for x direction is pulling it this way, plus the tension in the bottom x is also pulling it that way. So I like to say that all forces pulling to the left equal all forces pulling to the right equal to Fc. And then what we want, and then what we do want to do for y. So similar thing we have here. We have T top go, the tension of the y is the only thing pulling it up. So that means we have just T top y on one side. On the other side we have Fg pulling it down plus tension bottom of y, because that one's technically pulling it down. So these are our two equations. In addition, let's use this time to write out what Ty and what the y's and the x's are. So what this, let's do the top one first. So we got 45 angle here, and that means that Tx, it's opposite, so it's going to be equal to sine 45 T top. Ty is going to be cosine of 45, which is actually kind of useful because cosine of 45 is equal to sine of 45, so we can't actually substitute these in for each other, which will come in useful later in this problem. Then we have T bottom, this is T top y, T top x. T bottom x is going to be equal to sine 30 degrees, since that's 30, times T bottom cosine 30 TB. Yeah. So at this point, we have all these equations. You're probably wondering what we're going to do with them. What we are going to do with them is we're going to take, you know how we set it up so we have the y direction, TBY, and TTY here, and the x's here. We're going to plug, basically, we're going to plug these things back into here. So instead of having 4 unknowns, we only have 2 unknowns. So that's going to make our equations T top times sine 30 that was the bottom x. So this is sine of 45 plus TB times sine of 30, and this is going to be equal to Fc. Fc is equal to the mass times v squared over r. Let's then do the same thing here. We have TTY. We just plug this in. We get cosine 45 times T top, which is going to be equal to mass times gravity plus cosine 30 multiplied by T bottom. And then from here on out, the main thing we just want to do is combine these equations and simplify. So you know how I said that cosine of 45 equals sine of 45? We're just going to this is where that comes into play, because since those two are equal, we can replace cosine of 45 with sine of 45 down here. And suddenly, this part is equal to this part. So we can just substitute this equation into here, which that will give us mg plus cosine 30 multiplied by TB plus sine of 30 also times TB equal to mass times V squared over R. And from here we just want to take our mass gravity, subtract this over, as well as divide out, or this will leave us with subtract that over. We're going to get at this point I'm also going to plug in our values. So we're going to get TB multiplied by cosine 30 plus sine 30 is going to be equal, after I'm going to plug the ball mass, the radius, the mass, and the velocity, to get 16 newtons minus mass gravity times the mass, so 4 times 9.8. To make it simpler, I'm going to say that gravity is equal to 10 meters per second. So that minus 40 newtons. And after that we just divide the cosine over, and we get, or we get cosine 30 plus sine 30. We add those up and divide that over. To get our answer of negative 19.6. So our bottom rope will have a tension of negative 19.6 newtons. And so one thing that might come up first is, why is this negative? And the reason that it's negative is because I originally drew this tension as going this way, which was not the actual direction it's pulling. In truth, the rope is pushing out this way, which is why when we had to go this way, it was negative. So if you have a force that's negative, it likely means that you had it on the free body diagram, you had it going in the wrong direction. That being said, I don't think you will lose points for it, as long as you keep it negative, and that it is consistent with your equations. So that's just my thought on that. But now that we have the bottom, we also have to find the top rope, which is just TT. We are just going to plug this value into one of these equations. Let's do this one. So we got sine 45 T top is equal to mass times gravity, which is 40. We decided it was 40 newtons because I was lazy. And then plus cosine 30 multiplied by negative 19.6 newtons. And from here on out, we just need to multiply this through, solve, and that's algebra. I don't want to waste any of your time. So the answer to this one is 20. Oh dear. Well, it's 24.7. I'll just go to the other page. So it's 24.7, and you see how since the tension is positive, that means that we did have the right direction for this. It is indeed going down, pulling it back this way, whereas this tension is pushing it up this way. And with that, I think we are done here. If you have any questions, go on Teams. I will not be in the SAS room tomorrow, so this is pretty much the only way to reach me. But yeah, good luck everybody, and do well on the tests. I believe in all of you.